Physics Form 4, Chapter 2, Force and Motions, 2.6, Force. So that's the velocity. The higher the velocity, the higher the momentum. If both m and m also high, v also high, we'll get even more higher the momentum. Okay, and then you learn how to about principle conservation of momentum. Then we come to know the momentum is preserved before and after. Okay, then you come to know the combination. From the principle is when you able to create such the formula, okay, in order to find the mass before and after, in order to find the velocity before and after. Okay, that is the idea. Do a lot of exercise due to momentum, you will get a better understanding. Today we're going to further our study on 2.6 force. Okay, of course you have ever heard the word many times, even in science, Form 1, Form 2, Form 3, I believe you know what force mean, and you're able to give example of force. Okay, how to make a force? You kick, you slap, you pinch, you tear, and you do whatever the verb is. You jump, you kick, and there is example of how to produce a force. Okay, let's read this. Most of our daily activities involve forces. A force can change the state of motion of an object. Okay, correct? How does a force change the momentum of an object in motion along a straight line? Do you understand this one? How does a force change the momentum? Can force change the momentum? This is why at first place you learn momentum before you learn force. You know already what momentum is. Momentum is the the value belong to something that move, that has mass and in a motion. Okay, and you know the formula for momentum, P equal to mv. Now the statement say that force can change the momentum. Force can change the momentum. Okay, let's say we have this object moving to the right at certain speed v. This object has mass, so if we multiply m and v, we get the momentum of the object. But you know what? How can force change this the value of this momentum? If we exert some force to the object. Okay, before the object move with fixed speed, that is velocity. Okay, not increase, not decrease. At some speed. But suddenly we come at back here and push the object. Means that we put a force upon the object. So guess what? What can you say about this V now? When there is a force exert on the object to the motion the object or the motion of the object is. What can you say about this V? Will it remain the same V, or will it decrease or increase? Which one? It will increase. Increase the speed. It will increase the velocity. Let's say before the velocity is 10, let's say meter per second. But this time after some force being exerted on it, now what happened? The velocity this time become increase, and it raised up to, let's say 20 meter per second. Yeah, you know what? Before we multiply the mass and the velocity before, let's say the mass is 1 kilo. 1 kilo. So 1 kilo multiply 10, we got the momentum. That is 10 what? 10 kilogram meter per second. Okay. But after some force being exerted on it, this time let's calculate the momentum. Okay. Which the speed is increased to 20. This time we have 20, 1 kilo, the same, multiply 20, we have V equal to 20 kilogram meter second negative 1. So you see, it is true that if we how this force can change the momentum. It's quite easy to understand, isn't it? Okay, how does a force change the momentum of an object? Okay, and so if you do the opposite way, let's say you put a force on the opposite way upon the object, okay, means that what will happen to this V? It will decrease, correct? It will decrease. Okay, from 10, eventually it will become, let's say 5 only, 5 meter per second. Yeah, you do the same to find the momentum. 5 multiply the mass, what there is 1 kilo, and at last you'll have 5 kilogram meter per second. See, before momentum is 10, now it is 5. To this explain to us how this force can change the momentum. Okay, you understand? Simple pimple. Simple pimple only. Followed by that, we have a little activity for you. Okay, under this activity we have 2 parts of investigation. The first part is to investigate the relationship between force and acceleration. Second part is to investigate the relationship between mass and acceleration. Okay. Now, you know what? We want to know more detail about force. The symbol of force is F, capital F, correct? And we want to know what factors that can affect this force. You understand? What factor then that can affect this force? Okay. It is a mass of the object. Is it the mass can affect the how many force required to being exerted on this mass? If we put more load, mean we increase the mass, what will happen to the force? Or vice versa, if we exert a force, a bigger force or a small force to this object with got different mass, what will it be? So does this mass affect the value of force? And then what will happen if there is a force exerted on the object, on the mass? Something will happen, and what will happen is this: A, acceleration. Do you understand this one? Let's say we have a car here. This is a car. Now, this car has mass. Okay, this car has mass. Sorry, we got another car. Okay, this is a car. We got big one, we got small one. Let's say like this. Okay. Okay. This is big car, this is small car, means that the mass, which one is higher than which one? Which one is the higher in mass? Is on the left side, right? Okay. The right side here got less mass. The idea is, if we exert the same force to them, the same force F to them, we've been fair, we exert the same force to them, okay, which you come to know that they have different M. Now let me ask you this: something will happen to them, correct? And that something is this A, acceleration. And let me ask you this: which one going to go with high A here? Which one going to go with high A? The small mass or the bigger mass? Which one? Out of the same force. The same force, remember? Which one? Can you imagine that? Let's say you throw something. You got two rocks here. The small one, the bigger one, means small mass, bigger mass. And you throw by your hand. The same hand means the same force, the same force you throw. Okay, first you throw this, the bigger mass, and second you throw this by the same hand. Now let me ask you, which one do you think will be thrown faster? The bigger one or the small one?
Small.
Small one. Okay. Okay. And that is what happened. You see that if you throw both with the same strength, that is with the same force, because you use the same hand, and you will see that the smaller one, which you understand got a small mass, what happened to it? go a little faster. In this case, it go with a high acceleration than this, which got a high mass. Okay, that is the idea. So means that what I want to say at first place is, does this component mass have something to do with F? Yes, of course, because as you say, the smaller one, you see how it's affect this force. The smaller one tend to travel more faster than the bigger one in mass. So this is why mass here really got something to do with F. And A here is a consequence. A consequence, you put the force. A consequence if you throw. Throw means you put a force on the object. So now, how do we relate? Three of them. How do we relate three of them? And eventually make a formula which relate all of them, three of them. That is the idea. Okay. So in order to do that, you know what? When it comes to experiment, we only need to test only two things. Okay. And the other factor that will affect, we will have it to be what? To be fixed. To be fixed. It will become fixed variable. We don't want to disturb it. So we'll get the a good result. So this time we want to compare between F and M. While this A become fixed, we do not change this A, we do not disturb it. Okay, let A be the same. Okay, we just want to see, we're going to manipulate this value of M here, the value of mass, and we'll see how this F going to react, or vice versa. We're going to manipulate the F, and we'll see how this M going to mass, force and mass, okay, mass and acceleration. Okay. This is why we have this activity. Okay. Remember the idea. Sorry. If some factor, as I told you a long time ago, if the factor help the whatever that is on the left side, so we put it at the same level. But if the factor which the opposite way, then we have to put it on the below side. Okay, you understand this? This is how we made a formula. So let's go for this activity. Activity 2.13. Again, is to investigate the relationship between force. What is the symbol for force? It is F, capital F, and acceleration. That is A, A, with fixed mass. Oh, this time they want to test this F and A, without disturb this M. Okay, let's see the result. Means that if A increase, what will happen to F? If A decrease, what will happen to F? So then they know where to put A, on the same level of F or the opposite way, below. So here is how we set up the experiment, the apparatus and the materials. We have a retort stand, we have ticker timer, we have ticker tape which install inside through the ticker timer. We have current supply, we have a trolley, we have the runway for trolley. Okay, so we set up this trolley to become friction compensated runway. If you understand, what does it mean? Friction compensated runway. It means that how do we raise this high until the trolley neither stop, neither move with acceleration motion. So it will move only with a certain velocity, certain speed. This state is when we call friction compensated runway. Okay, neither stop because it is too low, and if we raise it up, if it over, it will make this trolley go with a motion of acceleration. We don't want that. We don't want the trolley to stop. We don't want the trolley to move with type of acceleration. We want it to be in a middle, that is velocity. Okay. And then first the trolley we take close to the ticker timer, and then we start ticker timer and we release the trolley. And you know what will happen, because of the attraction of gravity downward, the trolley will start moving along the runway. Okay, move down along the runway with a fixed velocity. Okay. Oh yeah, we also install this elastic string. We put on the trolley, and we pull, and then we pull this elastic string downward. So the idea is to exert the force, to give the force to this trolley. Okay, this time this trolley got a force from we pull, and not from the gravity, not from we increase the incline, but we pull the string. Okay, the idea is this time we're going to manipulate the value of force. So the idea is how to manipulate the value of force is by using number of elastic string. The first one, we use one elastic string. Okay, and then we're going to repeat the process with a new ticker tape. Then we're going to this time do with two elastic string. What does this mean? One elastic, two elastic. It means that we increase the value of force, because you know when there is more when there is more elastic string, there will be more force exert on the object. That is the idea. And then we add some one more elastic string, it become 3, means 3 times force. And then we'll see what will happen to the you know what, once there is a force, exert on the object will move with what kind of motion? We only have two kinds of motion, that is number one velocity, number two is acceleration. So in this case, whatever object that been exerted by force, absolutely the object will move not anymore in motion of velocity, but is in motion of acceleration. This is why we got the table for you to calculate the acceleration. Okay, means that this is the source, this is the consequence of this factor. Okay, one elastic, how many, what the acceleration is. Two elastic, what will happen to the acceleration? Yeah, but you know what the quick idea is? The idea is, if one elastic, yeah, we will have some only a little acceleration. If two elastic, the acceleration supposed to become higher, correct? If three elastic string means three times of force, mean the acceleration will be way much higher, correct? That is the idea. Okay, this you find this U and V and T here from the ticker tape lah, as you learned before, chapter 1, remember that one? Okay, you feel all of this, and you know how to find A out of this U, V and T. You learn the formula about A, U, V and T. Remember how to find A is by find the change of velocity, the final velocity minus the earlier initial velocity, and then you divide by time taken, correct? This is how to get A. Okay, and at last, you know what? At last, let's come to conclusion. We find out that after doing this activity, we find out that how this force relate to the acceleration. Okay, how this force relate to the acceleration? We find that the higher the force exert, the higher the acceleration. See, I told you, if this factor help this, then where we need to put this A? On the same level or on the opposite level? Which one? We're going to put it on the same level. Okay, like that. F equal to A. Okay, or we could say what is the relationship between F and A? We can relate it as you learned before. Remember that one? How to make a relationship between the factors. Remember the word directly proportional. Do you still remember that one? Directly proportional, inversely proportional, increase linearly, decrease linearly, increase and decrease. Remember, here it is. Okay, 1.2 scientific investigation. Okay, if this x increase as this y increase, so does this x y increase? Is how do we say it? The relation y is directly proportional to x. That is the idea. If it is decrease like this, decrease, we say decrease linearly. Or like this, we can say inversely proportional. Means that this x is decrease while this y is increased. Okay, so that is the idea. That is the idea. Now we have found out the relationship between F and A. The only thing that left is M, the relationship between M and A. Yeah? Where is it? Okay, this is for second part. To investigate the relationship between mass, the symbol is M, and acceleration A. Yeah? How do we going to relate both factor? Another idea is, will this A help M? Means that if A increase, M also increase. Or is it inverse? If A increase, is it the M will decrease? Which one? Okay, this is what we will find out in this activity. Yeah? At a constant force. This time we make the force to be constant. We do not disturb force. Okay. So how to set up this? This is how you set up the experiment. The same, you're going to have this trolley to become at state friction compensated runway, and then you're going to manipulate the mass by adding more trolley. So this is why you got a table which this time before we got different string. Okay, this time we have different mass. 1 trolley, 2 trolley, 3 trolley. Okay, refer to different mass. M trolley, 2 times M trolley, 3 times M. Okay, this time you're going to use only one string. Okay, if you can use 2 string, but make sure all of them you use the same string. That is 2, 2, 2, 2. Okay, because we want to fix the value of force. We don't want to change it. And guess what? We want to see what will happen to the value of A. If we increase the mass, will the value of A increase or decrease? Can you imagine? If we increase this mass, what will happen to the acceleration by the same force? Can you imagine this? We exert the same force to trolley with which only 1 trolley, and then we exert the same force to trolley with 2 trolley, and then 3 trolley from the same force. So can you imagine what will happen to the value of A? Can you feel it? The higher the mass. Okay. Have you ever pushed the trolley? You go to Billion, we got a trolley to fill the whatever goods there. Goodie. Okay, chicken, fruits, vegetable, whatever that is. You have this trolley. Okay, and you push this trolley. Okay, you push this trolley, and guess what? Before this trolley is empty, you exert the same force by your own strength, the same strength. Let's say 100 Newton. Remember, the trolley is empty. And what will happen to the A? The trolley will go faster, correct? Means that if the trolley is below the mass of the trolley is lower, the acceleration of trolley will become higher. Correct? After some time, you feel several things there. Means the trolley this time has increased in mass, and you know what? You start you push the trolley with the same strength. That is the same force, mean 100 Newton. But this time, what will happen to the trolley of this A? It will decrease as m increase. So the idea is, what is the relationship between m and a? How do we make a relationship between m and a? This is what will happen. If there is more trolley, means more mass, means that the trolley will move slower of the acceleration. So how to make the relationship? Before we have F and A, F is directly proportional to A. Okay, but this time between M and A, how do we make a relationship? Is M is inversely proportional to A. Means that we're going to have this A to become reciprocal of A, 1 over A. This means that, how to read this? We read this as this: M is inversely proportional to A. Okay. So means that M on the upper side, while A must be on the lower side, because A doesn't have M. M doesn't have A. If A increase, M decrease. If A decrease, M will increase. Okay. So if we combine all of three of them together in one formula, what will it be? What will it be? Okay, what will it be? Okay, we know that. Okay, I need another paper. Oh, sorry. Okay, we know that F directly proportional to A, while M inversely proportional to 1 over A. Okay. So if we do the algebra transfer, we're going to have this: A inversely proportional to 1 over M, correct? Okay, and this, I want this to change the place, to flip. So A directly proportional to F. So we have both A at front here, at front, and we have a factor on the right side. Okay, remember, whatever factor that help him, in this case A, we put on the upper side. Okay, this time we change this symbol to this symbol, equation, and this M is inversely to this A, inversely proportional. This is why we're going to put M under. So guess what? Here it is. We have derived a new formula that related between three of them: F, A, and M. Okay, and yeah, of course, if you want to do algebra transfer to have whatever the value, whatever the variable is, let's say we want to have a variable of f, okay, this m we're going to take on the left side, so at last it will become f equal to ma. This is the new formula for you, which relate between three of them, which you're going to getting used to it when come to calculate something between them. This is what the new the idea of how to derive a formula. Okay, any question? No. So continue. So this is what graph may look like. If we for activity number 1, between f and a, the graph will look like this, which is directly proportional. And for activity number 2, between a and mass, okay, we'll also have this kind of graph, because we already do the reciprocal for this m. If we don't do this reciprocal yet, the graph will look like this. See, the graph will look like this. Okay, this is a, this is m. It will look like this. It decrease. Okay, because we make this modification, it will become like this. Means that this m here, we make it reciprocal. So it will look 1 over m. And this is when we get the straight line like that. Okay. But still, the way we read it is inversely proportional. Where are we? Okay, so let's continue. The relationship between force F, mass m, and acceleration a for an object in motion is this. Okay, F directly proportional to m and a. Okay. If we change, if we substitute this value of a here, do you still remember what is the formula of a here? A, how to find a? We take v minus u divided by t, correct? Okay. Now let's say if we change this a here, we change to this component, what will we have? We will have like this, v minus u multiply t, correct? Okay, and then we expand the factor mv minus mu divided by t. Okay, here it is. Expression of Newton's second law of motion. Okay, finally it become like this. So what is up there? What is up there? Do you recognize something up there? mv. mv is formula for what? And also mu here. Mass multiply velocity is formula for what? Is formula for momentum. Is formula for momentum. Okay, formula for momentum. Mass multiply v is a formula for momentum. Okay, such this case here. Okay, before we got 10, after we put a force, we got the momentum increased to 20. So this is mv. Okay, this is mv, and this is mu. Yu because initial velocity, correct? Mu. So mv minus mu here, mv minus mu is what we call mv minus mu is what we call change of momentum. Like your height, your height today, your height is 1.5 meter. Okay, tomorrow your height increase to 2.0 meter, let's say. Okay, what is the change of your height? What is the change of your height? You're going to take final height and minus with the height before, correct? And it become 0.5. So this is what you call the change of height. And so does this. Why cannot we use the same term? We take this mv, we want to find the change. How many change? 10 to 20. We take 20 minus 10, correct? And so does this. This 20 here represent mv. This 10 here represent momentum earlier. So mv minus mu is what we call the change of momentum. Okay, so up there is how to say this. Mv minus mu, we say the change of momentum divided by t. What is t here? T here we read it as rate of. Okay, first, if we want to read this formula, we going to read the t below here as rate of, and then followed by you read whatever up there that you come to know already. Mv minus mu is this change of momentum, and then both you combine both, it become rate of change of momentum. Okay, so that is another name for rate of change of momentum. If you notice, we got double off here. Rate of change of momentum. Another name for this so long term here is force. Simple name, force. So if you don't want to use the word force, you can use this word, which is too long, rate of change of momentum. If you don't want to use this rate too long, because too long, rate of change of momentum, you can use only short one, force. You understand? Okay. And guess what? This is what Newton's second law. Second law. What is the first Newton's first law? You have learned before. That is the what? The inertia. Remember, inertia is Newton's first law of motion. Okay, state that blah 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 blah, object at rest, object at uniform velocity, and blah blah blah. Okay, Newton's second law is this formula, F equal to ma, or the long definition is this. Newton's second law of motion state that the rate of change of momentum, here it is directly proportional to the force. Okay, to the force. F, directly. See, this symbol directly proportional to the force. And acts in the direction of the applied force. From the relationship, okay, K is a constant. Okay. In this case, K is 1. Okay, here it is. In SI unit, 1 Newton is the force that produces an acceleration of 1 meter per second when applied on a mass of 1 kilogram. As such, 1 Newton equal to K multiply 1 kilogram multiply 1 meter per second. And this is why at last we'll have K equal to 1. Therefore, we no longer need to put the value of the K here. Why? Because 1 multiply MA is MA. Is why not the K is no longer need to be we put there. Okay, we can take out K. Okay, so the last formula that we have is F equal to MA, which relate to all of them. The factor A as acceleration, M as mass, and F as force. Okay, understand? Soon you'll find a question which asks you to find the rate of change of momentum. Do not get shocked. You know what this word mean? It means they want you to find the force lah. They want you to find this F. Okay, you're going to write this formula and fill the value of M and A and eventually find the value for F lah. Understand, kid? Okay. Where is it? So here we almost finished. Okay. Solving problems involving the formula F equal to MA. This time, let's see how they use this formula. When they use this formula. So, example 1, a worker pulls a load of mass 80 kilogram. So you going to need a drawing. As usual, you need a drawing. Pulls a load. Let's say here is a load. We got a trolley there with some load there. Some worker pull it. Okay, I don't know how to draw it. Okay, just simple one. This load got a mass of 80 kilogram. Okay, 80 kilogram. Okay, along a horizontal surface by a force of 160 Newton. So this hand exert a force of 160 Newton. Okay, like that. If the surface is smooth, another information for us means that there is no friction. So we don't have to worry about the force of friction. Okay, and without any resistance, such as air resistance maybe, that opposes the motion of the object. What is the acceleration? The symbol for acceleration is A, of the load. Okay, what is A? Okay, what is A? So, what is the formula which related three of them, F, M, and A? That you already derive it on yourself. That is F equal to MA, correct? Okay. Okay, this time they need you to find the value of A. They want you to find the value of A. Okay, so you do the algebra transfer, you take M to the other side, and it will become F divided by M. Okay, this time you take a chance to substitute all the value that you know. F is 160 Newton. M is, which the force exert on it is 80 kilo. Okay, like that. Press your calculator, and at last you'll get Newton kilogram -1, correct? Here it is, the value. Oh, sorry, because Newton here, we can simplify the unit. Newton is kilogram meter second -2. Don't forget this kilogram here. Okay, so this kilogram we can eliminate with this kilogram, correct? And all that unit that left is meter per second. 2 meter second -2. And this unit is belong to A, as we want to find acceleration. This is how you use this formula and solve the problem. Okay, so the idea is the force exert 160 Newton to this object which has mass 80 kilo, and what will happen to this motion? It is kind of acceleration motion, but with what value? The value is this, to be accurate, 2 meter per second. This is how you use the formula. Okay, so the time has come. There is another example for you, okay, and a little practice for you. You do it yourself. You do it yourself. Okay, if you don't able to find the solution, then tell me later. We are going to do it together. Okay, until now, let's meet again on the next day. Okay, jumpa lagi. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Waalaikumsalam.
Yeah,
Thank you, sir.
yeah. Physics Form 4, Chapter 2, Force and Motion, 2.7, Impulse and Impulsive Force. So we have done until this example 1. Now let's continue example 2. A car of mass, this is symbol M, moves with a velocity of, this is symbol V. Okay, a little drawing for that. We got a car, simple one. This car has mass M, 1200 kilo, and move with kind of motion V, a fixed motion, a uniform velocity, 30 meter second -1. When the brakes of the car are applied, the car stops in 5 seconds. So start from where the brake applied until at this distance, let's say, it takes how many times, how many duration? It is 5 5 seconds. 5 seconds. Okay. Calculate the average braking force of the car. Calculate the average braking force. Average braking force, the force lah of the car with symbol F. Okay. Now, how about you find it before me, Everybody? Force. So what the force for braking the car? What is the force? Okay. So here is the force which act opposite way of the opposite way of the direction of the car. Okay. So okay, now we take out the formula which relate between mass force and acceleration. In this case is deceleration, correct? Because this point to this point is deceleration, or means velocity decrease. Okay, so here it is, the formula which involves those three components. Now we've been asked to find the value of F. All we need to do is we substitute the value inside. M is 1200 kilo, while A is, okay, remember that since this is deceleration, is why we need to put negative, because it is a vector. Okay, negative. Oh yeah, here come another problem. We don't know the value of A. Okay, but we know the value of V from earlier motion, and the value of V, the final motion, because the car will fully stop at this point, means that this is, we know the value of velocity, final velocity, which is 0, because it fully stopped at this moment. So this V we have to use, because it is initial velocity. We need to alter the symbol. We need to use symbol of U. Okay, so we might not get confused later. Now you have learned how to find the acceleration out of these two information, U and V, and the time taken from U to become V. Okay, and the idea is to find the value of A is final velocity minus with initial velocity and divide by time taken. Okay, and if you fill that up, you count it, you get the answer. So V we got 0 minus negative 30, and then divide by 5, divide by 5 seconds, meter per second. Okay, press your calculator. So we'll have negative 6 meter per second. This why negative here, from doing a calculation, why we have negative is to is telling us that the acceleration is deceleration, means that it try to decrease the speed. So here it is. Now we have a value of a. We substitute in here negative 6 meter per second. Okay, keep moving. Press your calculator to have the value of this. One thousand 200 multiply 6, and we have 7,200 kilogram meter per second, or the derived unit for that is Newton. Okay, so here it is, the force applied to brake this car start from this initial velocity 30 until it come at rest, v equal to 0 velocity, which the time to do the deceleration is the time taken is 5 seconds. Okay, I want you to be able to read and try to connect all of them like that. So this force is 7,000.
Tak kena ada negatif kok.
Negative. No, you do not have to put negative. Oh, sorry. because negative, sorry. Yes, of course, sorry. Okay, this why force is negative? Because
Deceleration.
because the not because deceleration is shown in this negative integer negative for acceleration, but this time the force itself is negative. Why? To show that the force exert on the motion is the opposite way of the direction of the motion. This car moved to the right, correct? While this force exert on this car, which moved to the right, is on the opposite way. This force exert to this car to the left. So this is why the we got negative here, state for that. Okay, negative here, A here means deceleration. Negative in this force mean the force being applied in the opposite way of the direction of the object. Simple situation, but you need to be able to relate between each component involved. So the idea is this F here is we can say this negative 7,200 Newton has been applied to this car, which has mass of this which make this car happen to decelerate, which begin the deceleration begin with initial velocity, that is u here, 30 meter per second, and it takes 5 seconds to come at fully stop, which is the velocity is equal to 0. Simple one, but how do you going to relate all of them together? You should mention what is the fact, what is the effect, deceleration. Okay, start from where? Start from what velocity until what velocity? Okay, how many times it takes to do the deceleration? You could be able to relate all of them. Okay, you understand me? So there you have it. If you don't understand, do lots of exercise. Okay, now we moving along to this formative practice 2.6. Okay, let's do this. Let's see whether you can do it or not. Have you done this on your own? Okay, don't have to wait for me every time. You can do yourself. Question number 1, a force F acts on a body of mass 5 kilo. Okay, a little drawing for that. Okay, let's say this is the body. We got a force act on the body. Okay, we put a arrow like that from behind, from left, pushing this object to the right. Okay, of mass 5 kilo. Okay, we write down all the information given in the picture. A, if the body accelerates, uniformly from 2 meter per second. Okay, this is u. Okay, initial velocity to this is v. So u to v, we see the speed is increasing, right? The speed is increasing. Another word for accelerate. Okay, correct. Determine the, so wait, we need to transfer all the data here. So here start with u equal to 2 meter per second, and it raise to v to 8 meter per second. Okay, this is how you're supposed to draw. Determine the value of f. Here it is. You need to find this value of f. Okay, so what happened from this point until this point? It is acceleration. Acceleration A. Okay. Okay, we need to find the value of A. Can you do it? How to find the value of A? Acceleration from this point to this point. It's the same idea. Okay, so you know that you got to v here, to velocity, and this is when you can find the value of A, acceleration. If the body accelerate uniformly from, determine the value of f uniformly from uniformly. Wait, we kind of missing something. You know what that is? Aren't we missing something here? It is a time taken from this point to this point. So how do we supposed to find the value of A if we got not enough information? Time. Did we miss something? If the body accelerate uniformly, determine the value of F. Another information, if determine the displacement of this B here got nothing to do. No extra.
Uniformly.
Sir,
Ya.
dalam konteks kami dia tulis 2 second.
Hah? Wait. Oh, I know. This copy is got a little got a print problem. Oh, I see. I think I know. This first version they got a problem. Wait, let me check on textbook. Bahasa Melayu textbook. Where is it? Oh yeah, they have a error there. Okay, so it is 2 seconds. It is 2 seconds. Okay, need to alter something here. T is 2 seconds. 2 seconds. Okay, thank you for that. If we don't know this, not enough information, even one, then bye-bye. We can never be able to solve any problem. So here it is. We got from this U until this V, or is what we call acceleration. It takes this acceleration happen in T equal to 2 seconds. This is how you're going to relate all of the component. So now this time we can find the value of A. You know the formula already. Okay, we substitute V is 8, U is 2 meter second negative 1. You can do like this. You can put the digit inside the parentheses and the unit is outside because both of them share the same unit. Okay. T is time taken to do the acceleration is 2 seconds. Now 6 divided by 2 we got 3 meter. This second we take up there, and of course we have as negative 1. Since both is the same or the same, we can combine, so eventually it become negative 2. Is what the unit for acceleration. Negative 2. If negative 1 here refer to velocity. So you need to always check your unit to ensure that what you are looking for is correct. The unit belong to the correct physical quantities. Okay. We still got a long journey to go because the question first asks the force. Okay, still need to move. Now it is time to come to relate what formula which relate to F, M, and A, which you come to know already. F equal to ma. Okay, we got the value of m, we got the value of a. This time we substitute all the value that we know. A 3 meter per second. Okay, 15 kilogram meter per second, or the derived unit for this is as simple as Newton. Okay, so here it is, what we are looking for. So the idea is this 15 Newton force being exerted on this object, which this object got mass 5 kilo, and what happened to this object is this: it happened to move with type of motion that is acceleration, which the value of acceleration uh, is this 3 meter per second, which it start from initial velocity 2 meter per second, and it lasts the acceleration at v equal to 8 meter per second, which take duration 2 seconds of this acceleration to happen. Okay, that's how you supposed to relate. Imagine in your mind, try to cover all of the components together. Okay, we go to question number 2. A force of 80 Newton, we do B here. If F equal to 10 Newton, okay, if F equal to 10 Newton, before 15, we get 15. So question B, if F here is 10 Newton, okay, determine the displacement of the body. Do you know displacement is S, the distance, the symbol for displacement is S, okay, small s, of the body 6 seconds after the body starts to move from rest. Determine the after the body starts to move from rest. Oh yeah, they continue the journey. Wait. From rest means that this u here is no longer 2 meter per second, but a new u here is 0. Okay, we need to alter something there. Why? Because it mentioned that the body start to move from rest. Rest here give us the idea that u is 0. Okay, the time taken is 6 seconds. Okay, this is t. Okay, so t here is no longer 2 seconds, t here is 6 seconds. Okay, I believe you understand the situation. Again, this object exerted by this force 10 Newton, which it start from velocity 0 until 6 seconds later. This got nothing to do. What will it be? The displacement, S. What will it be? Okay. Okay. So, idea how to find the value of S, displacement. The displacement, the distance from this point until 6 seconds later. Okay. How? Come on, idea. let me ask you, can we have this value of A? The idea is the object accelerate, correct? Accelerate because it start from rest and it move with acceleration. Okay, can we find this value of A out of this information, force and M here? Yes, of course. Remember, we have this formula which relate among these three, which is this. Okay, we have the value of F, that is 10 Newton. We have the value of M, which is 5 kilo. Can't we find the value of A? Of course we can. We do the algebra. So A equal to F divided by M, correct? F we know 10 Newton and M we know 5 kilo. 5 kilo. So press your calculator, you'll get 2. So this Newton here, if we expand the unit to SI unit, we have kilogram meter second negative 2, correct? Okay. Kilo here, we can eliminate with kilo here, and all that is left is meter per second negative 2. Okay, which is the unit for A. Now we have a value of A. So can we find the value of S? We have A, we have T, we have U, 0, and we don't have the V. Again, we have A, we have U, we have T. Other than that, we need to find S. We have A, we have U, we have T, we need to find S. So this is all the information that we required, that we have, and the thing that we need to find S. Have you seen this somewhere? Have you seen this component somewhere? Do we have a formula for this?
Yes.
Do you still remember? Yes. Those four formula. What is the name for those four uniform linear motion? Here it is. Where is it? Okay. This. Remember this one? Do you miss this? Okay. Linear. This formula we call linear motion equations. Now back to use this. This is why we learn this at first place. Okay. Now again, we have A. Okay, we need to choose among those four which one is suit to find whatever we need to find. In this, do we have here? Do we have A in this equation? Yes, we do have A. So this here got no problem. This got no A. Bye bye. This got A. Okay, can be used. This got A too. Okay, can be used. Okay. How about U? Do we have U here? Yes, we have U. We have U. We have U. Okay. So not a problem for you. T. Do we have T here? Yes, we have T. We have T. We have T here. So not a problem. Now we want to look for S. Do we have S here? No, we don't Do we have S here? Yes, we have S. And so does this. Sorry. This cannot be used because we have, we have no V. So, okay, both cannot be used. Both cannot be used because we got no V. Okay. So, these two we cannot use because got no. Because have V here, we have no V. Okay, cannot be used. So the only thing that left for us is this. Okay, so you're going to write that formula down and start counting things. S equal to sud setengah 80 square. Okay, this is why you need to memorize all of this. Back to the question, where is it? Okay. Okay, we need to find the value of S. Okay, here we got already S on the left side. No need to do the algebra transfer. We just need to begin with substitution. U is 0. Okay, U is 0. And T is 6 seconds plus a half. A is that we acquired from this formula, 2 meter per second, 2 meter per second, and T is 6 seconds. 6 seconds, don't forget square, 6 seconds square, like that. Okay, since this is 0, we can eliminate them, and all that is left is this 2 here can eliminated with this 2, and all that is left is 6. This need to deal with this. Okay, before deal with this, 6 square is 36. Okay, 36 meter. Okay, do not forget to also square the unit. So it becomes second square. So this second square can eliminated with this second square, correct? And all that is left is meter. Is what the unit for displacement. See, I told you. So the answer that we are looking for is 36 meter. The idea is start from this point until this point, which takes 6 seconds. The distance is, the displacement is 36 meter. Okay. This is what physics is. Okay. Before we just learn, if you notice something in this formula, linear motion equation, is it? Where is it? How come we don't play with force, right? Before. So you see this linear motion equation here, 4 of them got no value of F. Okay. They just talk about the 5 components only. But before you able to come at this component, there will be a force which make all 5 components. You understand? This force, then it start to if there is a force, then it will be the beginning to all 5 components later. Like this case here, this F exert on this object, then start. We have the value of u, v, time taken, acceleration, displacement. That is the idea, is to combine this F and with those 4 linear motion equation. You understand me? Okay. Now, let's go for question number 2. A force. The idea is you need to deal with force in order to find the value of A, correct? The only thing that can be related from this between this formula and those 4 linear motion equation is yes, 5 component that involve this 4 linear motion equation is A, V, AU, V, T, S, correct? Okay, how to relate this formula to this formula is because in this formula we got something similar to this. And what is it? What is the component A? So the idea is sometimes they do the question, they give this situation, but they don't they give all the components except A, and in that situation they hide this A in this formula, which also they give the value of F exert on the object and also the mass of the object. So the idea is you're going to get the value of A from this formula, then you will back to use this formula in order to find another component, U, V, T, S. You got the idea? Okay, not difficult to understand. Moving along, a force of 80 Newton acts on a stationary. Do you understand what stationary is? Another meaning for rest. Okay, sometimes they call rest, sometimes they call stop, sometimes they call stationary, sometimes they call u equal to 0 meter per second. Whatever that is, all the terms refer to the same thing. That is, the object is at stop. Okay, stationary. Here we have stationary. Here means we have information that u equal to 0. This is very important. Do not take for granted for each word. It must have a clue. It must have a clue to answer the question, to find all the information needed to answer the question. So again, a force of 80 Newton. The same drawing, a simple one. Okay, we have force. Let's say this force on the back here, 80 Newton. Acts on a stationary object. Okay, stationary here means the u start with 0 for 7 seconds. For 7 seconds here refer to time taken to do the acceleration. Okay, until this point, let's say. So it takes t is equal to 7 seconds and cause the object to reach a velocity of this is v. Okay, final velocity. So here it is where you put v, 35 meter second -1. Question, calculate A, the mass of the object. Underline mass turn to symbol M. Okay, oh, this time they want us to find the value of M, the mass for this object. Okay, again, I'm going, now how you going to imagine to relate all of the components? This is how you read the situation. The force 80 Newton exert on this object, which move this object from U, that is 0, to V, that is 35 meter per second. And from U to V, it takes 7 seconds. Okay, again, this 80 Newton exert on this object, which has mass of this M, which move this object from U, 0, until it increase the speed to 35 meter per second, which in this motion, U to V here, it takes 7 seconds. Do you understand that one? You should be able to relate all of them. So let's begin. Yeah, once we see this M, we know that the formula is only this, which involve M. Those 4 linear motion equation doesn't have M, so it couldn't help much. You understand? Okay. So we want to find this M. Now we check all the components. Do we have it or not? Oh, yes, F here we have. A here we don't have. So how to find the value of M if we don't know the value of A? You understand me? Can we find the value of A here? Can we find the value of A?
5.
How to find the value of A? So we need this this equation. Okay, we want to find the value of A. We know V, we know U, we know T. Let's substitute. So we have 35 meter per second negative 2 divided by 7 seconds. Negative 1. Okay, 35, 7 is 5. Both can combine, become negative 2. So here it is, the value for A. Okay, now we have the value of A. Can't we find the value of M? Of course we can. First we do the algebra transfer to get the value of M, to get the variable that we want, F divided by A. Then we substitute the value F. We have 80 Newton. A we have 5 meter per second. We know the unit for Newton in SI unit is kilogram meter second negative 2. M here can be eliminated with M here, and so does this as negative 2, and all that is left is kilogram, is what the unit for mass, correct? 80 divided by 5, we get 1.6 kilogram, and here it is, the mass for the object. Now you got the idea. So you see, the idea is you kind of need to combine. In the story, sometimes we need to combine all the formula. F equal to MA, A equal to V minus U over T, and those 4 linear motion equation. Three of the formula come along to solve some problems involving motion. Okay, a quick idea for you. So next time you won't have a problem to solve the problem. Then moving along, this time we need to find the displacement of the object. The displacement is S. Stand for S. Okay. So the idea is, how long is this? Correct? How long is this distance? Okay, we need to find the S. What is S? Here we know already, 5 meter per second. So we put here A. Now, can we find the value of S? Yes, of course. Here, all of this component, A, V, S, T, U, V, is the consequences coming from this force. So now they can stand alone. Okay, you can play all alone, all of them, all the consequences from the using the formula ELM, linear motion equation, LME. Okay, LME. Do I have to show this to how to find S? No need, you know your way out lah. Okay, and that's all for this subtopic 2.6. Any question? Any question? Is everyone okay? Any question? If you don't have problem, then we can proceed to next subtopic 2.7. Okay, no problem. When do we finish? Is it 10:10? It is 10:10.
Yes.
Okay. If got no problem, then